Hello, welcome to the next session for the data science training. My name is Razzaghi, and today I'll be going through some of the information about data models and why we use them and how PEDSnet uses data models in the work that we do. And I'll explain a little bit of the data models as well. So let me share my screen. Go. I will. Slideshow. All right. So as I said, this week we'll be going through the PEDSnet data science training and focusing on the data model. So as an agenda, I'll start with an introduction of our kind of the role that data models plays in the data coordinating center and in PEDSnet. Then I'll provide an overview of the different types of data models and kind of what the point is. Then the PEDSnet domain overviews, kind of how the data, I'll go through example tables of the data model, and then kind of some of the adaptations that we have made to PEDSnet to the OMOP data model specifically. And then some of the remaining tables that we have added in PEDSnet, and then the process of requesting updates to the PEDSnet data model. So let's start with an introduction. So in the PEDSnet Coordinating Center, there's several things that we do, including data pipeline, data modeling, data quality, and data science. And the data, it's interesting, the data model and how we use it plays a role in all of this, both in the data pipeline in terms of the data transformations and derivations, data modeling, how we represent data in our database, data quality, understanding how the data behave and whether there's face validity and able to understand fit for use research, and then in doing our data science work and query fulfillment. So in terms of the data models overview, this is kind of the data flow in PEDSnet in terms of where the data is going and how it flows. So there are a number of sites in PEDSnet, and then the data all get transformed into a common data model, and that's what we mean when we say the data model. And then from the data model, as I kind of demonstrated in the intro slide, there are several activities that we do. There's data quality, query fulfillment, data science, and et cetera. And so this flow of data from the sites to the end product requires some sort of transformation, requires an ability to standardize data. So the question is, why do we standardize data? So I think in previous lectures, we talked about the EHR and how there's different data structures within even two institutions who use Epic as their EHR. There's still a lot of variation in how the tables are structured or how they're populated. And so because of that, we require, there's just different semantics and impossible to be able to kind of use in big data if they're not standardized in some way. And this also goes into the different environments as well, how workflows affect the representation of data. So the goal is the consistent data semantics. So we have PEDSnet ETL conventions, and they're in GitHub and they're publicly available. And then the data that are transformed into the data model, as you can see here, this is taken from the Odyssey website for the OMOP common data model, but really it's true to any kind of data model. It takes the different sources and transforms into similar meanings so that they can then be leveraged for you know, the science and research and so on. So the OMOP Common Data Model is a standard way to represent the data structures and content. It's one model, and it's meant to be able to harmonize data coming from disparate data sources, so administrative claims, EHRs, registries, and etc. And why? So that we can enable the standardization of data. And so a visit will mean the same thing across all different resources, all different institutions, and be represented in the same way, rather than across, you know, having meanings that are kind of hidden behind variables that are ambiguous and don't mean a lot to someone who wants to use them. The PEDSnet data model is much the same sort of content and rationale, but some of the differences between PEDSnet and OMOP is that in PEDSnet, the vocabularies are less standardized. OMOP has kind of more rigid ways of standardizing vocabularies in their data tables. So for example, in OMOP, all conditions are standardized to the SNOMED ontology, whereas in PEDSnet, there's more of a reliance on kind of pulling whatever is from the source, as long as it's a standardized vocabulary. So ICD-10, SNOMED, and etc. Though in use most of the time, PEDSnet relies on the ICD-10. And then there's also just some larger structural differences. So in OMOP, there's one table to represent all drugs, and then within the tables, it's flagged as to kind of the type of drug. And then whereas in PEDSnet, there's, I think, 4 different drug tables. And similar with labs and vitals in PEDSnet are separated, whereas in OMOP, they're kind of combined into one. In terms of the way that the networks operate in OMOP, the Odyssey community is kind of different communities, almost operating autonomously, whereas in PEDSnet, it's more of a structured network with queries being passed and distributed in SAS. So this provides an overview of the OMOP Common Data Model with the left-hand box showing, and so this is taken right from the Odyssey website. So the left box represents standardized clinical data. So all of the conditions, drugs, procedures, devices, measurements, and then as you can see, the vocabularies all flow into these tables because they're all standardized to a particular vocabulary. So they're represented by this idea of concept. So a concept is, you know, a diagnosis code, for example. And then these tables have metadata about each concept, and then these are represented in all the data tables. These are really the most common tables and formats that we use in our analytics. So, but we also use a lot of the standardized health system in this box as well, where care site and provider are kind of metadata about the visit. So for example, if you wanted to understand the provider specialty for a particular visit, this would be provided in this table. And then there's the health economics, where this is more cost, which PEDSnet does not populate, but we do have visit payer as well. And then these are tables that are kind of more metadata around, so condition error, arrows of diagnoses, drugs is how long a person was on a particular drug. So this is derived from the tables, for example, the drug table or the condition table. So the PEDSnet data model overview, as I mentioned, we have all of our conventions publicly available on GitHub, and the link is right here. So the data model is captured in person, fact, observation, and vocabulary tables. it's the PEDSnet data model is almost completely aligned with the OMOP data model, some key differences, which we'll go over a little bit later. And just like any kind of database table, there are primary keys, which are unique to each table. So in the person table, the person ID is the primary key. And then there's condition occurrence ID, visit occurrence ID, and these are unique IDs for those tables. Then, as we said, the concepts are captured through the concept ID. And so, for example, drug concept ID is an RX norm code to represent a particular type of drug. And then a primary key in one table can be a foreign key in another. So the person ID, which is the primary key in the person table, goes into all these other tables as well. And those are foreign keys. So in the visit table and the condition table, the person ID is found in there. And so if there's a person ID in the visit table, it should be able to find its way back to the person table, that same person ID in the person table. So these are some standard fields for the data model. So all the fields is the table name and the ID. So typically primary key. So for example, the measurement ID, which we just went over. And then the condition concept ID. So the table name, which is the condition occurrence table. So the condition concept ID. And so those are the concepts. So the example here is the condition concept ID for croup. Then there's the star type concept ID. So for example, this is kind of metadata around the concepts. So as I mentioned before, how in OMOP and therefore in PEDSnet, we keep all of our drugs in one big table, and we use this field drug type concept ID to flag whether it's prescriptions or inpatient orders or inpatient administrations, and et cetera. Then the start date, so the visit start date indicates the start of a visit instance. And then these source values are meant to help with representing the source systems, kind of the vocabularies or the structures in the source systems. So if we start with the person table in PEDSnet, and again, this is it is identical to OMOP, we have the person ID, the provider ID, location ID, care set ID, and then the concepts, and then some more metadata. So in the person table, for example, the person ID is the primary key, and the provider ID, location ID, and care set ID are foreign keys that go into, so provider ID is the primary key for the provider table, but is meant to provide information about kind of the provider who is either the primary care provider for a particular person in this table, or the provider in which that patient has the most number of visits, if a primary care, if it's not easily distinguishable. And then there's the gender, which is the race and ethnicity that are also found. And so for the gender concept ID, we also have gender source value and gender source concept ID, and et cetera. And then we have year of birth, month of birth, day of birth, and birth date time. And actually in PEDSnet, we added another field for birth date, which is just kind of truncated from the birth date time, since we have used that field a lot. So the visit occurrence table, we have the visit occurrence ID, which is the primary key, and then the foreign keys, person ID, provider ID, and care site ID. So rather than, so in this visit occurrence table, the provider ID here is the provider ID in charge of a particular visit rather than at the person level, so that regardless of who their most frequently visited provider is, if their visit is with an oncologist for a particular visit, then that provider ID is associated with this visit occurrence ID. And then the visit concept ID tells you whether it's an outpatient, inpatient, emergency room, telehealth, et cetera, encounter. So these are all kind of metadata around the visit. The most common And then the visit start date, visit end date, and date time are date and date time information about when the visit started and ended. So these are kind of the most commonly used fields, particularly the visit occurrence ID, person ID, and then the provider ID and care site ID, as well as the type of visit and then the start and end date. So then we have clinical tables that capture patient level clinical information. So each row in each of the fact tables is a unique observation of the concept for the patient. So the clinical tables in the common data model are diagnoses, which is found in the condition occurrence table, procedures, which are in the procedure occurrence table, drug administrations, and the drug exposure table, and so on and so forth. So I'll go through a few of these tables. So in the PEDSnet condition occurrence table, all codes are entered as conditions and are able to be mapped back to ICD or SNOMED codes. So it's standardized to the SNOMED CT ontology. So all of the concepts in the condition concept ID will be standardized to SNOMED. In PEDSnet specifically, the diagnoses should be clinician-based and not billing, so that so for example, if someone is using Epic, there's some terminology that there's more of an interface that the clinicians interact with, and those are called intelligent medical objects. And those then get mapped to SNOMED CD concepts. And those are the diagnoses that are represented in the condition concept ID in PEDSnet. And I'll go over this a little bit later, but given the kind of ubiquity of ICD codes, we also capture ICD and represent it in the data model. Though again, we standardize to, we actually in our analyses and the way that we work with the data, we almost exclusively use SNOMED CD. And we also collect IMO codes when possible in order, but we don't ever use them for analyses. They're more just to help with debugging. So the PEDSnet condition occurrence table, these are kind of the top conditions in PEDSnet. And this is meant to kind of show that sometimes what we expect to show up as top conditions are not. So the most common condition table in PEDSnet is called the patient encounter status. So not an actual kind of ailment or, like asthma or something like that. It's just kind of a code that is used to represent that a patient was seen at an encounter. Well child visit, vaccination needed, and etc. These are all the most common diagnoses. So I think it's always interesting to see that. So in the condition occurrence table, the table is structured again with the primary key of a condition occurrence ID with foreign keys of the person ID, visit occurrence ID, and provider ID. So the condition occurrence ID is the unique instance of a particular condition with all the different metadata around it in the table. So it's the unique identifier in this table. And the person ID is the person. The visit is the visit in which the diagnosis was made. And so you could imagine a visit might have several diagnoses. And so each of those would have a separate line in the condition occurrence table. And the provider ID is meant to be the provider who assigns the condition, though in PEDSnet we've never actually kind of validated this field. We mostly use the provider ID assigned to the visit. So the condition concept ID is, again, in the SNOMED CT ontology. And then we have the condition source concept ID, condition source value, and condition type concept ID. And in PEDSnet, we use these fields a little bit differently than in OMOP. We try to kind of, given how important diagnoses are in phenotyping and analyses, we try to spread as much as we can to understand how the diagnoses are being pulled and what's happening at the clinical encounter. So for each condition concept ID, we pull the source value. But in the source value, the IMO code, that is associated with or mapped from the IMO code that maps to the SNOMED CT concept that is represented in the standardized field. And then also we collect the ICD term as well, so the billing diagnosis. Again, these are not meant to be used in a lot of analyses, but mostly they help to debug and help us understand when and if there are discrepancies between diagnoses, why that might be the case. And then the condition type concept ID here describes whether it was made at an inpatient, outpatient, or ED position, or as a problem list entry. And the condition start date, which sometimes gets confusing, is not the date that the condition actually started in the patient, but the that when that instance of the condition was recorded in the EHR, so the time of diagnosis. So it'll be a lot of times aligned with the visit start date as well. Then we get into the PEDSnet drug exposure table. So these drugs are standardized to the RX norm, and we capture prescriptions, dispensing when available. I think maybe one site or two sites provide dispensing data for us right now, and we rarely use it. Inpatient ordering and inpatient administration. So the fields with variable data quality because of source ambiguity, we have been trying to improve the frequency, dose, and quantity, given that a lot of studies are interested in looking at, for example, disease exacerbation, which is most often caught by increasing a dose of a medication or the frequency or something along those lines. So these are kind of works in progress, but things that that we've been hoping to improve. So in the drug exposure table, we have the drug exposure ID, which is the instance in which a drug was either dispensed, prescribed, given as a inpatient administration. There's the person ID, provider ID, visit occurrence ID, the drug concept ID here, and then the drug type concept ID. So the drug concept ID is the RX norm code, and then the drug type concept ID is where it was given. So prescription, inpatient order, etc. And then these are a lot of the metadata. The drug exposure start date is the dates of the order and the start time and date, and then all of the metadata. And I'm being mindful of time. So this is mostly to kind of describe how we capture drugs and the RX norm hierarchy, but that will be explained in a future presentation about the specific vocabularies and kind of the RX norm hierarchy. But mostly the PEDSnet data, we tried to identify drugs at the most granular level available. And again, when we create code sets for studies, there's a lot of ways in which we can capture it. So at the ingredient level, for example, prednisolone is one ingredient, but could be represented in 423 potential ways. So then there's a procedure occurrence table. And so this is any action other than medications. So office interventions, laboratory testing, diagnostic testing, etc. And these are, or should be, completed orders. So actually in OMOP and in PEDSnet, there's 4 different types of vocabularies or terminologies that are accepted in the procedure occurrence table. So the CPT, HCPCS, ICD procedure, and even SNOMED. We most commonly see CPT and ICD in our procedure occurrence table. So often finding procedures is is interesting and sometimes challenging because they can be represented in different ways. So, for example, if you order a blood panel, the results will be in the measurement table, but the order should be in the procedure table. And sometimes the condition occurrence table will have diagnoses, like, for example, a kidney biopsy is a procedure occurrence, but often these are diagnosis codes as well. So sometimes it's interesting where these end up. So in the procedure occurrence table, we have the procedure occurrence ID as the primary key with foreign keys of the person, provider, and visit occurrence, the procedure concept, the procedure type concept ID. And here, what we try to represent here is whether this is a billing or an ordered procedure, and primary or secondary. The measurement table are discrete results. So as I mentioned before, if there's, for example, a blood panel ordered, the discrete results are in the measurement table here. And so there's the laboratory testing. We also collect PFTs. We have anthropometrics as well as vital signs. And so there are specific vital signs in PEDSnet that we require, and not all of them. So a list of those can be found in the conventions, the ETL conventions on GitHub. So if you want to find measurements, they're usually in the measurement, and as we mentioned before, the order itself would be in the procedures. In PEDSnet, which is a little bit different than the structure of OMOP, which we'll go into a little bit later as well, the differences. But we split measurements into kind of three domains: measurement labs, measurement anthro, measurement vitals. And really, when we say we split it, the table is partitioned in our database, and the reason for that is because for example, if you are after BMI Z-scores, you don't want to sort through billions of rows of blood pressure measurements. And so partitioning helps to kind of make the queries more efficient. So this is the structure of the measurement table. So we have the measurement ID, person ID, visit occurrence ID, and the provider ID, and then the measurement date. So a lot of the same type of structure as the previous data. So again, the primary and foreign keys, kind of the vocabularies, and then some of the metadata around dates. And then specifically for the measurement table, we collect information about specimens. So a urine creatinine is very different than a serum creatinine, and so there's metadata to kind of modify the loin code that's associated with it, and then some of the output. So there's ranges for like normal ranges for labs, and then kind of the value. So value as number is if the lab is a quantitative lab, value is concept ID, which is if it's a qualitative, so positive, negative, or something to that extent. I think okay. So the PEDSnet standards and adaptations here. We talked a little bit about these as we were going through some of the tables, but we've made some adaptations to OMOP, mostly to meet the complex needs of a pediatric data system. And so some of those we have expanded value sets. So the visit concept ID includes visit types that are not specified in OMOP. So for example, we have a separate clinician face-to-face visit concept ID that's different than a visit that is mostly meant for imaging and lab visits. We created another visit type for observational visits. which are, I think kind of unique to PEDSnet. We have new tables. So we have an ADT occurrence table. So this is mostly meant, and we added this a few years ago, to identify administrative transfers to the ICU. And so I think OMOP is working on a visit detail table, and I haven't been as up to date on those conversations, but this was created a few years ago in PEDSnet because of the desire to kind of understand clinical kind of decompensation in patients and being able to distinguish kind of what was a severe outcome in a patient and what was not, based on kind of the judgment of transfer to ICU. Then there's the immunization table, which provides all immunization data, the measurement organism table for blood cultures specifically. We also, in the versions of our database, we have separate tables that kind of pull out source values so that we can, instead of searching the bigger table to kind of debug, these are meant to kind of help us debug more efficiently. And then I already mentioned the partitioning that we do. We also do a lot of data derivations as well. So the measurement anthro table, the anthrometric partition table for measurement, includes derived heights and weights and z-scores and BMI values. So here I mentioned earlier about how PEDSnet has specific standards for source values. So here, you can have in your source, so these are taken directly from the ETL conventions, but so if you have in your source system IMO, then that's what is usually the interface for Epic users, for example. Then the condition concept ID would be the corresponding SNOMED concept, and then the condition source concept ID would be the ICD and ICD-10 mapping, usually the billing code there, and then the condition source value would be the diagnosis name, pipe, the IMO code, pipe, and then the diagnosis code. So the reason, again, that we do this is to help with for standardization. I'll give actually two kind of concrete examples of when this came into when this has helped us with our analytics. So we recently looked at MISC in children, and so MISC is the inflammatory condition that's has been found as a complication of COVID-19 in children. And what we have found is that only about 72% of the time has MISC been found in the in standard concepts in the PEDSnet database, both with the ICD and SNOMED terms, were not specific enough to be able to capture the MISC diagnoses. And it could be because it was a new diagnosis, or there might be something else going on. But because we collect kind of the source value and being able to kind of query that field, we discovered that. Another way that that this has kind of helped us is by understanding. So in a study where we are looking to identify children with a condition called spondyloarthritis for a clinical trial, what we realized is that there's a specific SNOMED term that is used that is specific to spondyloarthritis, and if you pull from the IMO term that and go directly to the SNOMED mapping, rather than through the billing code, and the billing code is this non-specific code that could mean spondyloarthritis or could not be spondyloarthritis, you end up misclassifying a lot more patients if you rely solely on billing. So the way that we've set up this structure kind of leverages the ability to use SNOMED to kind of represent complex condition coding, as well as being able to use these other fields to debug when needed. And this goes through sort of the guidance of how to set up the source values for different drugs, and the mappings. Again, these are reviewed a lot in the conventions, but just trying to, the way that PEDSnet kind of uses source values and source concept IDs sometimes are a little bit different than the way that OMOP leverages them. So I'm going to skip this. So then as I mentioned, we have some additional tables here that we use. So the measurement organism table is a completely new table that we use it contains organism related to laboratory culture results. ADT occurrence is the ICU table, and the immunization table is new too. And then in the observation table is a table that's in the EAV structure in OMOP, and in PEDSnet we use it to represent discharge status, tobacco use, smoking, birth information, and DRGs. In the COVID era, we've also been using a separate, the same structure to identify kids with lab confirmed COVID or diagnosis confirmed COVID, and et cetera. So the table is set up very similarly, but with more flexibility. So the observation ID is the unique instance, the primary key. And here the observation concept ID is the information about the observation of interest. So it can be anything. It can be birth date, birth information, or tobacco use, or one of these concepts that we created. And then you can have value as number, value as string, value as concept ID. And the value as string here is new, and it helps to, we already reviewed value as number, value as concept ID in the measurement table. The value as string allows string responses too, if needed. But we, again, rarely use that as we try to convert everything that we have to a standard concept. The provider and care site tables, as we reviewed, these provide metadata, including the specialty, and mostly we use it to identify the specialty of either the provider or the care site. And the specialty concept in PEDSnet is actually unique to PEDSnet, I believe. I don't think OMOP has yet adopted a care site specialty, but we use it because we found that a lot of our sites use a specialty for care site rather than like a facility, for example, a nephrology clinic, and they're better at identifying those than provider specialty. Then we have visit payer, condition error, drug error, observation period. So these are all, again, PEDSnet and OMOP and tables, but these are the visit payer helps us to understand the visit level payer information. So the insurance types, and the condition error, drug error, and observation period are derived tables. So the last thing I'll just quickly go over, the process for data model changes. We are constantly updating the data model for based on several, study requirements, data quality issues, and just improving how we want to represent information in the in our database. And because of that, we're constantly evolving and constantly updating these specifications. So this presentation was meant to provide kind of like an overview of the data model, why we use a data model, and the structures of the table, and some of the adaptations we made in PEDSnet from OMOP. But really, the details and the convention are found in the conventions, and are meant to kind of be the source of truth for everything. So when there's changes, there's a whole governance process in which the request is evaluated based on kind of current priorities and analytic needs and kind of the governance of the network. So usually these are reviewed at steering committee meetings, and then if updates are required, then are taken to the data committee and the data models work group to talk about implementation of the changes. So that's all I had. Thank you very much for joining. I know I went a little bit over time. Please feel free to reach out if you have any questions about anything I have gone over today. Thank you.